In this video, I'm going to show you how to reflect and translate the graph of the absolute value function. This way, we can learn to graph absolute value functions quickly without having to create a table of points. First off, we're going to graph the regular absolute value function. We already know that looks like a v. And then we're going to use this function, the regular absolute value function, to graph its negative. When we put a negative in front of the absolute value sign, every single point flips over the x-axis to have the negative y value. So, for example, 0 stays the same. This point here goes to down here, keeps the same x value, but its y value changes from positive to negative, and all the other points follow suit. Similarly, on this side, this point here flips over and takes its negative y value, and all the other points on that side also follow suit. So it's like the x-axis is a mirror, and we've just reflected this function y equals absolute value of x over the x-axis. Let's tackle some more complicated equations, where we also have a constant that's added or subtracted from the absolute value. To graph these, we're going to start off with the graph of y equals a negative absolute value of x, because we need to follow the order of operations. Order of operations tells us that we first have to multiply the absolute value by -1, and then we can add or subtract outside the absolute value. So we're going to take the graph of y equals a negative absolute value of x, and then we're going to shift that accordingly. To graph y equals a negative absolute value of x minus 3, we have to shift all the y values down by 3. In other words, we're translating this graph down by 3. So this y value at 0 goes to here at -3, and all the other points follow suit. So that's the graph of y equals negative absolute value of x minus 3. Now to graph y equals negative absolute value of x plus 4, we have to take all the points here and translate them up by 4, because the y coordinate is increasing by 4. So 0 moves to 4, and all the other points follow suit. And there we have the graph of y equals negative absolute value of x plus 4. Now let's talk about what happens when we're adding or subtracting by a constant inside of the absolute value. So order of operations tells us that before we do the reflection, before we multiply the absolute value by -1, we have to first add or subtract inside of the absolute value. So we're going to start off with a graph of y equals absolute value of x. And then to graph y equals negative absolute value of x plus 5, we're first going to ignore the negative sign. We're just going to graph y equals absolute value of x plus 5. And when we're adding by 5 inside of the absolute value, we actually have to shift left 5. We have to shift -5. So we're translating the graph 5 units to the left. So we're starting here, and we're going up this way, going up that way. And that's y equals negative absolute value. No, that's y equals absolute value of x plus 5. Now, to get the negative there, we have to reflect that over the x-axis. So we're going to take this dotted graph and reflect it over the x-axis to get this resulting graph. And now that graph is the graph of y equals negative absolute value of x plus 5. Now, to graph this negative absolute value of x minus 2, we have to do the same thing. We first have to shift, we have to translate by the -2, and then we have to reflect it. So first we'll translate by the -2, and one that's inside of the absolute value, that actually turns into shifting 2 units to the right towards the positive side. So we're going to start here and then at +2, and then draw our absolute value of x dotted. So that's y equals absolute value of x minus 2. And then to take care of that negative sign, we're going to reflect it over the x-axis. So it'll look like this. There's our graph of y equals negative absolute value of x minus 2. For the final example, we're going to consider a case where we have adding or subtracting a constant both inside and outside of the absolute value, in addition to a negative sign in front of the absolute value. So order of operations says that we have to do the addition or subtraction inside the absolute value first, and then we can multiply by -1, and then we can do the addition or subtraction outside the absolute value. So first we're going to be doing the horizontal translations, and then the reflections, and then the vertical translations. Let's start out by trying to graph this function. We're going to break it up a little bit. First, let's consider just this x plus 2 portion, without the negative, without the +7, just x plus 2. So that's the absolute value graph, the normal absolute value graph, just shifted 2 units to the left. We're translating left by -2, and then so it'll be going up like that. But we're also reflecting it, so it'll be going down like this. So we'll draw that to keep the image in our minds. That's y equals negative absolute value of x plus 2. And then lastly, we have to shift that up 7 units. So we're translating up 7 units here. We're going from 0, we're starting off with the y value at 7, and then all the other points follow suit. And there's our graph. There's our graph of y equals negative absolute value x plus 2 plus 7. Now for this one, it's a really similar process. So we're going to start out, let's just look at the x minus 5 part. So that says to translate our graph 5 units to the right. So we're going to start here, and then the negative says to flip it over the x-axis. We're reflecting over the x-axis, and then it'll look something like this. Let's draw that just to keep that image in our minds. And that's y equals negative absolute value of x minus 5. And then the -2 part says that we have to translate it down 2 units because all the y values are having 2 subtracted. So every point shifts down 2 units. The point at 0 goes to point at -2, and everything else follows suit. So now we have a graph that looks like this, and this was referring to that. Now for this graph, that's our final graph. Y equals negative absolute value of x minus 5 minus 2. And there we have it. We're done. Graph here, graph here. So the general takeaway is that you just got to follow the order of operations for these and translate inside first. That's the horizontal translation. Then you multiply by -1. That's the reflection. And then you add or subtract outside the absolute value, and that's the vertical translation. In the future, we'll see what changes in the graph when we multiply parts of the function by some number other than -1 or +1. Like what if this were a -2 times the absolute value in front? We'll see that in the future.